You did? You did? Okay. Okay, okay. Let's do it. Okay, guys, so we continue doing the number 7 problem. No, number 7 problem we almost finished, but let me try to again. Taking this computer volume bounded by the two surfaces. The first surface is paraboloid, and the second is the plane. Okay, so now the sketch in 3D is okay. Basically, this is a paraboloid in which the z-intercept is 1. Open up, open up. I need to know only in the first octa. Octa. Basically, the sketch of the paraboloid look like that. Okay, this is the surface of the paraboloid. This is the surface of the plane. So now I want to do the triple integral. This 3D sketch. And 2D sketch is, for example, when you project it onto the XY axis, something like that. XY. It's a quarter of circle. However, I have no idea what is the radius, no? But the radius is easy. You intersecting both surfaces, and you enforce it to be 7 equal 1 plus 2x squared plus 2y squared. I move 1 to the right hand side. Subtraction is 6 and divided by 2. When you divide it by 2, you have 3 equal x squared plus y squared, and your identification clear. Okay, the intersection between paraboloid and plane is a circle. It's a circle. It's a circle. That circle, quarter circle. Okay, the radius is radical 3. And this is our region in 2D. Okay, we're using to compute the double integral. But the first of the triple integrals, you select cylindrical, go from the paraboloid side to the plane. Okay, so one more time we have C simple. We go, when you set out the triple integral, no green, triple integral, the integral function is 1 because it's a volume. The first stage of integration, I suppose, get DC, and DC go from the paraboloid. Look, paraboloid is z equal 1 plus 2 common factor x squared plus y squared. Entonces x squared plus y squared in cylindrical is r squared. So I go from 1 plus r squared to 7. This is easy. So now Jacobian are the theta. It's easy because in polar in 2D I saw que the radius go from 0 to radical 3, and the theta is an angle que scan from 0 to pi, 0 degree, 0 radian, pi over 2, 0 to pi over 2. This is my triple integral. So you this integral, integral 1 is just c. Evaluating between this is 7 minus 1 plus 2r squared. It is actually 6 minus 2r, 6 2r square, no? And you replace you replace the next integral is the integral for the r, pero r contain one extra r, entonces r, the integrand function is 6r minus 2r cubic, integration from 0 to radical 3 dr. This is one integration. The part is 6r squared over 2 minus 2 r4 divided by 4, evaluate in between 0 and radical 3. Well, actually this is 3, no? We cancel out, it's 3. And this is 1/2. Entonces es 3r squared minus r4 power divided by 2, evaluate in between 0 and radical 3. Well, this is 9 because square root 3 squared is 3, 3 times 3 is 9, minus, entonces square root 3 raised to the 4 power is square root 3 raised to the 4 power is equivalent 9, no? Because we can interchange 3 to the 4 power, que es 81. It's 81, entonces 9 over 2. And 9 over 2, so 9 is 18 over 2 minus 9 over 2 is 9 over 2. It's a coincidence. Okay, now finally, the easy part. Okay, the easy part is the last integral of the constant, okay, 9 over 2 d theta. D theta go from 0 to pi over 2. Integral d theta is theta, evaluating between this and this is 9 pi over 4, because these two and these two multiplication, 2 times 2 is 4. And it's the final answer. Any question? Easy or complicated? Opinion? Opinion, guy? Answer me. It's clear, it's confusing. Omar, Brandon, clear. Carlos Duque, clear so far. Okay, clear so far. Okay, let's go move on to the number 8 problem. Number 8 is a typical of we are using spherical coordinate. And number 8 is compute the volume also. Compute the volume of the solid formed by x squared plus y squared plus z squared equal 4. This is within, so inside this sphere. This is a sphere. Below the cone or the semicone, no? Half of cone is z equal square root x squared plus y squared. It's a cone. And compute the volume again. Compute volume. Okay, volume. Okay, let me try to do the sketch in 3D. Remember, the sketch in 3D is it's no super elegant. It's to have a rough idea how it look like and what surface stay the solid, no? It's bounded by the solid, no? Actually, we have a sphere. This sphere, the center, is located in the... So no specification first octant. So I suppose that we have surface in any octant. Well, no. A specification, for example, c greater than or equal to 0. But no limitation for the x and y. Entonces es obvio que es sphere o hemisphere, because this restriction limited the range of the sphere. Entonces the radius is 2. 2 positive, 2 positive, 2 negative, 2 negative. And the height is also 2, it's a sphere, hemisphere, something like that. Hemisphere. And we have a cone, pero this cone is, you know, any cone have two cone, no, a double cone, pero no double cone, sino it's only the top part of the cone. I know because this part, because it's positive square root, so this is our cone. Entonces, bueno, I suppose que the intersection between the sphere and the cone generate one curve like that. I have no idea. Okay, and the solid is inside the sphere, the hemisphere, and below the cone. So basically, my solid is that part. So not inside the cone, you know, below. So basically, it's one hemisphere. Can you remove the cone part? Okay, entonces, bueno, this is the 3D view. No good. Never is good. Well, good is in algebra. Okay, now to understand much better, we need to do at least 2D view. For example, I do the view in the plane XC because I want to see lateral view of this. The lateral view is, you see, we have this is the semicircle that represents the sphere, the radius 2. We have a cone. The cone look like a line. Okay, and this is our solid, or at least the lateral view, no, of the solid. Okay, another view is 2D. I need to understand very well the solid before doing anything. So you need to do 2 lateral view, is perfect. Or no lateral, in this case, 4 plan. On a 4 plan, we have XY, for example. We have one circle, okay, que represent the sphere, pero we're looking for the 4 plan. Okay, so because the radius 2. But we have another sphere here. Okay, I have no idea where the radius. And our solid is inside this ring. So little by little, you approach it to the. Okay. Let me try to understand this second circle. Que es this circle, is the intersection, and between the cone and the sphere. Therefore, I take both equations. I take the equation of this sphere, okay, is x squared plus y squared plus c squared equal 4. You take the equation of the cone. But you square both sides because I want to eliminate the square root. When you square both sides, entonces now it's obvious que it's the same cone, but it's a double cone. So when you have a square root positive, it's the top part. Square root negative is the bottom part. No square root is a double cone. But I don't care because I know the restriction que C is positive. Therefore, I know que it's a top cone, so the upper cone. So when you square both sides, we have c squared is equal x squared plus y squared. Suppose there are many ways to manipulate this. One way is, for example, you replace x squared plus y squared like a c squared. So we have c squared plus c squared equal 4. C squared 2c squared equal 4. C squared is equal to divided by 2 both sides, and C is square root 2 plus or minus, no? But actually it's only plus. I don't care the minus because remember C is positive. Basically, I discovered that this circle lie on the plane c equal square root 2. Entonces I suppose, bueno, si, for example, si I'm doing different, so I'm doing a little bit different, suppose, instead of replace c for x squared plus y squared, I replace in this way, x squared plus y squared, because I want to see the projection in xy axis. Entonces no es x squared plus y squared. It's similar, but you now replace z squared plus x squared plus y squared. We have 2x squared, 2y squared equal 4 divided by 2 everything, x squared plus y squared equal 2. Entonces you see more clear that this is a circle with the radius radical 2. That is a radical 2, it's a minor radical 2, it's a radical 2, it's a minor radical 2. Entonces, by the way, si C and R is the same, it's because this angle is 45 degrees pi over 4, no? And the Cont. Okay, entonces we are ready. We are ready to set out the triple integral. Okay, look at that. Let me erase this part. Totally. Okay, triple integral. So this is the total information that we need to set out the triple integral. Integral function is 1, but you're using a spherical coordinate. Spherical coordinate. Spherical coordinate always 100%. We use a rho symbol. So your integration first with respect to rho. Entonces, bueno, the Jacobian is, you know, rho square sine phi. Now your integration, the rho first, the phi second, and this order always, and the theta finally. Okay. Entonces, in order to see the rho, I recommend doing this 2D view, because I see in solid rho, que is the distance from the center to any point on the solid, is 2. In this branch and 2 in this branch is around. It's just 2. So rho go from 0 to 2. And phi obviously in the direct point go from 0 from pi over 4 to pi over 2. So my solid go from pi over 4. Okay, pi over 4 I suppose is the inner side of the solid to the last part is pi over 2. Remember, phi is a little bit complicated to understand because C is mixture from Z axis. So one angle exactly on the Z axis is phi is 0. Phi is 0. Phi is 0 here. Phi is 0. So my solid go from this side to this side. Okay, it's this side and this side. It's obvious que theta go from 0 to pi. Okay, we can separate in different integral. Of course we can. Okay, because the limit is a constant, and also the integrand function is separable. So we can separate, for example, the first integral sería from 0 to 2 or rho squared d rho. You take this, and this here. Rho 0 to 2. How was? How was? Okay, rho, remember, rho is the like a position vector. No, no exactly position vector. It's distant. It's the distance from the center to the any point on the solid. The our surface que bounded our compound solid is a sphere. Therefore, in the sphere, rho is constant, equal to 2, que es the radius for the sphere. Make sense, Gerardo? Yes or no? Answer me. Eso, bueno. Ajá, entonces yo separé here another integral, que es de integral que I separate the sine phi, d phi, no? Que go from pi over 4 to pi over 2. And finally, integral from 0 to pi of only d theta. This is easy, elementary, kindergarten. This is 2 pi, because the integral antiderivative of the d theta is theta in between 0 pi. This is 2 pi. This one, bueno. This is a antiderivative sine is minus cosine, no? Minus cosine, evaluate, minus cosine theta. Evaluate in between pi over 4 and pi over 2. Let's do it. Minus, parenthesis, cosine pi over 2, minus cosine pi over 4. Bueno, cosine pi over 2 is 0. Cosine pi over 4 is radical 2 over 2. We have double minus, and so the answer of that part is radical 2 over 2. And finally, the part here is rho cubic divided by 3, evaluating between 0 and 2. Entonces 8 over 3. That's what the final answer. And the final answer is 2 pi times radical 2 over 2 times a over 3. These two is cancelled. And stay alive. A radical 2 pi over 3. This is the final answer. Let me copy in my paper because I forgot to copy. I don't know why. Okay, this is pi over 4. Pi over 4, pi over 2. Pi over 4, pi over 2. The answer is this is positive radical 2 over 2. And finally, multiplication everything. I copy in the other page. Is a radical 2 pi over 3. Any question, guys? What part is confusing? Do you understand the beauty of the conversion in another coordinate? Because convert in the specific solid, not in every solid, but in a specific solid, convert my complicated problem, can Cartesian look like crazy, to one triple integral que contain limited constant, and this triple integral with limited constant, and the integral function is separable. Of course, we can separate in 3 simple integral like a calculus 1, compute separately, and finally multiplication. It's the beauty of this. It's fantastic, amazing, magic. Any question? Any question? I want to hear opinion. Opinion. Everything clear? This is a review, no? Entonces I need to know si es clear or no for you. A ver, Carlos Duque say something, pero I don't. Carlos Duque. Let me see in the chat. Typing in the chat or activate the microphone. Yes, sir. Okay. This was number 8, no? Okay, number 9 is a little bit different. Okay, number 9. The information is given is the one triple integral que somebody, not me, set up in Cartesian. Somebody, not me. Okay. Integral function is xy, and the order of the integration is this. Entonces dice evaluate the integral by changing the spherical coordinate. Because partition is crazy, super. Entonces I need to change into spherical. Okay. First of all, I need to understand the solid associated with this triple integral. Entonces this value is obvious. See, my first order is DC is because this is C. Okay, the C go from the C of the cone, which is this, and the C of the, it's obvious that this is a sphere, right? Or hemisphere, at least a hemisphere, it's obvious. 2 minus x squared minus y squared. It's correct, guy? Do you understand that this is a hemisphere? Hemisphere. Well, so you don't understand if this is a cone. Okay, we can separate because it's a radical. Well, no, okay, yes or no, Gerardo, look. Okay, let's do it like a kindergarten guy. Look, you separate this equation and you copy, not like inequality, sino like equation. C is equal square root 2 minus x squared plus minus y squared, and you square both sides, you have c squared is equal 2 minus x squared plus y squared minus, again, carajo. Okay, if you organize, move the variable to the right hand, to the left hand side, and you organize in alphabetical order. I suppose that you see clear now that this is a sphere. This is a sphere, and the radius is radical 2. And the center and the origin. Of course, you need to understand that when this is totally sphere, full sphere. However, in our problem, no, a hemisphere, because it's a radical, so it's like a explicit equation in which somebody, not me, isolate the C and apply square root both sides, so we have the hemisphere, the top part of the hemisphere. Likewise, so you take here this equation is square root x squared plus y squared equals C, and you square both sides. If you move every variable to the one side, oh, we have a cone. It's clear. Identification super clear now. Yes, a cone. Remember, cone is a surface. You have complete collection of the x, y, and z, but in the direction when the cone open, so this is the cone alone, the z-axis is negative. And another way to identification of a cone is because the right hand side is 0. See, the right hand side is a number, for example, 1, 2, 3, 4, 5. It's obvious que it's no cone. It's the hyperboloid one sheet. Okay, but in this case, a cone. Okay, so basically our surface que I need to do in 3D is hemisphere and cone. Again, similar to another problem, no? Similar. Entonces, okay, let me try now to do. Oh, no. Bueno, yeah, bueno. Let me try to do the 3D picture, or at least one approach to 3D picture. Okay, look, 3D sketch. Bueno, 3D sketch is very similar to the previous problem. Not exactly. Okay, we have a sphere. I don't know if it's in the first quadrant or no. the first octave, or no? This is X, this is Y, this is Z. We have the sphere. Oh no, no good. The sphere. And the radio for this sphere is radical 2. So this distance is radical 2. This distance is radical 2. This distance is radical 2. And this distance is radical 2. And we have a cone. And the cone is like that. And suppose similar, you know, the intersection between the cone, okay, we computed before, after that, is something like that. It's a curve, the intersection between the cone and hemisphere. No? And the most important now is identification our solid. O sea, the guy que set up this integral, que by the way is doing in Cartesian, believe que the C vary from the C of the cone to the C of the sphere. Therefore, this is my solid. Or I don't know, see it's exactly like that, but I have roughly idea. Okay, so I need to understand the work done for another people que set out this triple integral. Okay, in this case, the C value go from the C of the cone to the C of the sphere. So this give me some idea. Okay, this is a 3D picture. Approximately, no good totally. We confirmed this 3D picture and the 2D picture. Okay, in 2D picture, well, you have similar situation. Suppose that we have the XZ axis, because I want to see the lateral view. We have a sphere or hemisphere. Okay, now you see a semicircle, radius radical 2, radical 2. The cone. And our solid in this case look like that. This is 2D. Lateral view. To complete the idea, I have another view in 2D. It's a full plan. It's XY. In XY, I see the sphere, but the sphere is like a circle, full circle, no? Okay, this is this part. However, I have another circle small inside. I have no idea for the radius. No, I have no idea. And it's a radical 2. So I need to find this. But it's easy. It's easy because it's this curve, okay, it's this circle, represent the intersection between cone and sphere. So I intersected both equations. So the equation for the cone was x squared plus y squared equals c squared. I take this, look. And the equation for the sphere is this. It's x squared plus y squared plus c squared equal to. And now you're intersecting. Well, there are many ways to do. In this case, I am doing replace c squared for x squared. So it's x squared plus y squared. Instead of c squared, now I put x squared plus y squared again, it's the same. No? In the cone surface equal to, we have 2x squared plus 2y squared equal to, divided by 2, x squared plus y squared equal 1. So I discover that this inner circle that represents the intersection between cone and sphere is the circle with the radius 1. And radical 2 is bigger, right? Okay, I finished. No, why no? Because I need, it was negative. Ricardo is it was negative. Okay, what's negative here, Ricardo? Look, in the cone. However, I move c squared to the right hand side, no? Become positive because for me it was comfortable doing that algebra in this equation. I manipulate in order to understand what is the intersection curve between the cone and the sphere. Make sense or no? Make sense or no? Good. Okay, now, okay. So, guy, listen to me. I need to understand the double integral. I think it means equation for cone. I think he means, yeah. You manipulate the equation. Never mind. Okay. You manipulate the equation and the way you consider better, no? The classic I have in my mind, memorized, is this, no? Is x squared plus y squared minus c squared equals 0. Identification. Wow, when I see that, I know que se come. But there are no contradiction, que I write like that. X squared plus y squared equals c squared because I isolate c squared because I want to substitution this here. Okay? Entonces I discover, wow, this equation is equation for that circle, the inner circle. Okay, now the complicated part, the tricky part, the confusing part. Remember, well, I understand very well in the triple integral, at least the C part, but I don't understand very well the dy dx part, so the double integral. The double integral, the guy can set up this integral doing in that direction, Wait, from 0. Look. Okay, pay attention. The region R, I saw que this guy doing in that direction. Pero doing from 0, look at that, from 0 to the circle with the radius 1. And finally extending this strip in the x direction from 0 again to 1. Therefore, our region is this. No, it's a quarter of circle. Guy, this is an important moment. Remember, somebody, not me, set out one triple integral using Cartesian. Okay. I need to understand the word done for this guy. Now, my goal is changing to spherical. I probably say spherical, no? Spherical. And solve it. Fine. Okay, do you understand this or no? Okay. Remember, two important things. And the triple integral. So I suppose que the guy que set out this integral using C symbol from the C of the cone to the C of the sphere. This is this part. Now I take care the double integral and the region R. I need to discover what is the region R. And the region R, he said, que go from 0 to the circle. Entonces es no full circle. No. It may be a semicircle or quarter circle. Pero x go from 0 to 1, entonces it's a quarter circle. Make sense or no? In my opinion, this is a complicated part. And be careful. And be careful with this situation because it's the integral doing by another people. I need to understand what is the solid, what is the region, and also I am ready now to set up the equation and spherical, changing to spherical. Let's do it spherical now. Spherical. Okay, let me try. Spherical now. Okay. Entonces now in spherical, well. It's doing step by step. I changing this integral in another integral, triple integral. Okay, first of all, I need to change the integrand function. Wow, integrand function is x times y. Wow, entonces x times y, I have no idea. X times 1, I have no idea. Okay, I know the equation of the conversion from spherical to Cartesian. I copy that. The equation is x equals rho sine phi cosine theta. Y is equal rho sine phi sine theta. And by curiosity, Jacobian, bueno, Jacobian, you know, is rho squared sine phi. I don't care Z because Z is not participating in the game. Entonces, you multiplication, x times y, o sea, you multiplication, this, times this, because of the Jacobian, right? I want to do everything in one step. Entonces, how many rows in total we have? 1, 2, 3, 4. Row 4. Sine phi. How many sine phi? 1, 2, 3. Cubic. Cosine theta. Sine theta. And the order of the integration always in spherical is d rho, d phi, d theta. Okay. Do you understand very well? Do you understand very well? Eso, bueno. Okay, therefore, the first integral is the rho simple. To understand rho simple, I can see, for example, in this lateral view, rho go from 0 to this. This is our solid, no? And this distance is radical 2. So it's from 0 to radical 2. And phi go from 0 to pi over 4. Okay, that angle, 0 pi over 4. You see, what about that part? No, that part is not including phi. It's including theta. When you rotate. And remember, we have no negative part. It's only the positive part. The theta go from 0 to pi. Yes or no? Everyone saw the limit? Pi over 2 is pi over 2 to pi over 4. No. Remember. This is complicated part. C, 0, so, C no, phi equals 0 represent exactly on the CX. This is no pi over 2. So we have a habit. Wait, our region is different from the last. Yes, absolutely different. Our region is completely different. It's another problem. In this case, look like ice cream, no? In this case, no, it's completely out the ice cream. Okay, this is different. It's different. It's not necessarily it's a coincidence. Hello, why? And then phi 0, o sea, normally the habit que we have in our brain is que theta equals 0. Bueno, theta equals 0 is obvious que es in the x-axis here. This is theta. It's easy to understand. However, phi is not easy to understand. Phi 0 is on the z-axis, and you walking in that direction. This is phi. So phi here is pi over 2. Phi here is pi. And that's it. And the range, pi, no pi over 2, pi. The range of the variation, C is from 0, exactly on the z-axis, and pi is the opposite direction from the z-axis. Then our problem, entonces from this point, que es phi equals 0, to this, que es pi over 4. However, does you say, well, what about that part? Well, that part do not exist, no? Because actually I discovered in one moment that actually we have only positive parts and my solid is different. It's like that, no? It's this part. And that part, I suppose in one moment, exists, do not exist, because the confirmation was here. And the first, opt-down. Entonces now, es obvio que theta go from 0 to pi over 2. Get this. Make sense or no? Everyone is clear or confusing? This is the 100. This is the challenge, guy. I give you in the test one integral. You don't know anything. How one people different to me, different to us, set out this integral in Cartesian. So I need to understand. After, when you understand the solid, when you understand everything, the solid and the region and the double integral, then you are ready to little by little set out the triple integral using the spherical, no? Okay, so now this is a moment. This is a moment to apply calculus 2. Fortunately, the limit is a constant. Wow. And the integrand function is totally separable. Therefore, I can convert this horrible triple integral in three easy. Bueno, easy no, it's not easy, pero bueno, es calculus 2, ¿no? Okay, entonces basically we have one integral, 2 and 3 integral, and for example, the first one is easy, it's rho 4 d rho. Grow from 0 to radical 2. This was easy. Another case, consider phi. Phi and phi. Sine cubic phi d phi. From 0 to pi over 4. This is a little bit complicated. This is a little bit complicated because we need to use substitution something. This is a typical trigonometric integral. And the last one is, well, it's relatively easy. It's from 0 to pi over 2 of cosine theta, sine theta, d theta. Okay, let's do it one by one. Let's do it. Of course, I want to start for the easy one. The easy one is the rho part. Rho part. So I copy. Integral from 0 to radical 2 rho 4 d rho. Well, the antiderivative rho to the fifth power divided by 5. No? Evaluate between 0 and radical 2. Okay, entonces like a radical 2 raised to the fifth power divided by 5. Entonces, you know, it's like a radical 2. Let me copy here to the fifth power. It's the same, no? However, fifth power is odd number. However, you break it down into 2 to the 4th power and 2, no? And this 2 to the 4th power is 16. Is square root 16 and 4. So 4 radical 2 over 5. 4 radical 2 over 5. I finished this. At least one. Wow, amazing. Let me go to the second in complication case this. Integral from 0 pi over 2 cosine theta, sine theta, d theta. Well, thus I can propose you do substitution. For example, si you assume, suppose que u is sine, du is equal cosine theta d theta. So I convert to another integral in which this is u and this together is du. And the limit, no, the limit is changed. The limit is grown for 0, theta 0 means que u is 0 because sine 0 is 0 and pi over 2 is 1. Wow, easy integral. Entonces this is u squared divided by 2, evaluating between 0 and 1 is obviously 1/2. Fantastic, we are the best. Calculus 2 was important. Okay, now let's go to the last one, because it's the most complicated. Okay, it's integral from 0 by 4 sine cubic phi d phi. This letter is phi. Phi. Okay? This letter no, es theta. Okay, but this is phi. Okay, now I try to break it down cubic like a sine phi sine square phi d phi. The limit stays the same. The only thing I did was break it down because I know using Pythagoras identity trigonometry this is 1 minus cosine squared phi. But you separate in two. Separate the first one is 0 to pi over 2 of sine phi d phi minus another integral from 0 to pi over 4 sine phi cosine squared phi d phi. Well, this is easy. This is easy because antiderivative is sine minus cosine. Phi evaluate in between 0 by 4. Is minus cosine 0, cosine pi over 4, sorry, minus cosine 0. Cosine pi over 4 es radical 2 over 2. O sea, es minus, paréntesis, radical 2 over 2, minus 1. O 1 minus radical 2 over 2. Good. Okay, this is this part. I need to complete the second part. The second part is is integral from 0 pi over 4 sine phi cosine square phi d phi. I suppose que cosine phi es u. And the derivative is minus sine phi d phi equal du. Entonces, to complete the differential, we need an extra negative. So I put the extra negative we need here. And we put a negative in order it doesn't affect my integral, no? Entonces, it's minus integral. Okay, this guy is u squared. And the rest is du. Okay, I create artificially include the negative one extra, du. And the limit, what about the limit? 1 on 0 phi is 1. Pi over 4 is radical 2 over 2. If you want, okay, because radical 2 over 2 is smaller than 1, and we have minus outside the defined integral, we interchange the limit like that. And it's pretty easy. This is u3 over 3, evaluate in between 0 no, coño. Radical 2 over 3 over 2 and 1. Entonces this is 1/3 when you evaluate 1 minus, I want to skip the arithmetic part, 2 radical 2 over 24. Now I put together this and this, remember. Entonces 1 minus radical 2 over 2 plus 1/3 plus or minus plus, yeah, plus 1/3 minus 2 because I changed the sign, 2 radical 2 over 24. And the answer, that part is horrible, is 8 minus 5 radical 2 over 12. I take this, and multiplication, everything. I did that, of course. You trust me, the answer is 4 radical 2 minus 5 over 15. It's the final answer. Any question? This is this is the most complicated part. And that complicated part deviate our objective is calculus 3 to calculus 2. So we spend maybe too much time. Look at that. This is calculus 3 to this. And this is calculus 2. And everyone making mistake and one stupid arithmetic operation, or you know. Okay, wow. Okay, number 10. Number 10. Let's do number 10. Okay, any question, guys? Any question? Do you understand the idea for the calculus 2, no? Yes or no? Yes or no? Yes. Okay. You don't forget calculus 2, no? Okay. Okay, let's move on to the example 10. Example 10 is similar. Example 10, mostly remember. Okay, now, okay. You know, this thing is very, very particular. No, normally you forgot because, you know, it's normal. The brain is amazing, no? Entonces now, when you don't touch something, you forgot. Let's do number 10. Number 10. Number 10. Okay, number 10 is, bueno, again, it's similar. Okay, now I need more participation. Voy a hablar de integral by changing the ferical. O sea, one guy, no me, doing this integral triple integral. It's similar, but be careful. Be careful. Entonces now the integral function is weird. It's 1 over c square root x squared plus y squared plus c squared. And the order of the integration is dc first, dy secondly, and dx last. Okay, so I need to understand the solid. I need to understand the region of the double integral. I need to change everything to the spherical coordinate, no x, y, z anymore. No. Okay, entonces es obvio que the first stage of the integration is dc. Therefore, c go from this surface, by the way, is a cone, no? It's a cone. It's the upper half of cone to the sphere. It's similar. It's similar to another problem. Okay. From the cone to a sphere. Okay. It's similar. So I suppose that the 3D sketch and this problem is exactly the same of the 3D sketch and the problem number 9, no? I suppose. I don't know. Just in case, let's do it. It's similar, no? It's the famous sphere. So I put intentionally this problem because it's similar, but no, exactly the same. Look. This is the famous sphere. Okay, by the way, the radio is radical 2, no? Because it's these two. And we have a cone. And remember, we have the curve that represents the intersection. KD before, no? The radius 1. The radius 1, yes. The radius 1. So this is 3D picture. Okay. And 2D picture is very, very similar. Very, very similar. This is my solid, no? Look, this is my solid. Again. Okay, formed by a cone one piece of the sphere, right? Now, here in the 2D picture, I discovered exactly the same. In the last problem, we have one circle with the radius 1. This radius 1, this radius no. This radius is like a 2. It's bigger. Okay. Okay. But this radius do not participate in the region. The region is, let me see, the guy que set out this triple integral. Okay, let me use in blue color. Suppose que the region in 2D is, I have no idea, okay, is y, and between negative square root 1 minus x squared and positive 1 minus x squared. Wow, so now the guy gets out this triple integral. When you are doing the double integral, I suppose that this is the strip. So integrate in this direction, vertical. From the negative part, is this, to the positive part, is this. Finally, extending in both directions, from negative 1, I suppose is here, to positive 1. Okay, conclusion. This is my region in 2D. No quarter circle like the other problem. You know, it's completely full circle. Okay, this is my region in 2D. So basically, when you're projecting this, it's a full circle. Okay, this is my region in 2D. Super. I like that. And what about x? Bueno, x vary. No, carajo. X vary from negative 1 to positive 1. That is the reason, okay, I understand. Okay, it's a full circle. Okay, ready. I am ready to change this integral to spherical. So I copy 3 integral. 1, 2, 3. Okay. Let me pay my attention in the integral function and the Jacobian part together. Well, I know the equation is C is equal rho cosine in spherical, cosine phi. Okay, and square root x squared plus y squared plus c squared is just rho. And the Jacobian is rho squared sine phi. Well, the rho, the phi, the theta. Okay, put everything together. So it's 1 over cosine, rho cosine phi, another rho, que is the big square root, and the top we have rho squared sine phi. D rho, d phi, d theta. Wow. How many rho is cancelled? Everything is cancelled because we have rho squared, and rho squared. And we have here together sine divided by cosine, que es tangent. So my new integral function is tangent phi. Okay, super. Okay, now rho. Remember rho symbol. Always we use it in spherical. So this means that your integration first will respect the order is classical. Rho first. And rho, I want to see one of you can do a lateral view if you want, but no, it's okay. In 3D it's possible to see. Basically, this distance. So inside the solid, always rho go from 0 to the walk of the sphere, que es radical 2. Entonces, rho go from 0 to radical 2. And phi go from 0 to pi by 4. And theta go from 0 to pi by 2. Pi by 2, no, 2 pi, because it's the full circle, 2 pi. And this is our triple integral. Any question? I want to solve it for now. I want to solve it, okay? Do you follow me? Everyone? Okay, good so far. Okay, good so far. Okay, so now, fortunately, we have limited constant, we have separable functions, and we can separate in three integral, no? The first one is integral from 0 to pi, d theta, good. Yeah, I know by memory the answer is 2 pi, no? Another integral, a little bit complicated, is from 0 to pi by 4, tangent phi, d phi. And another integral is super easy, is integral from 0 to radical 2, d rho, just the rho, because remember, any rho is cancelled out. And the answer of this is radical 2. Because integral with respect to rho of the rho is rho evaluating between 0 and radical 2 is radical 2. Entonces, the complicated is this one. Pero no big deal, no big deal. It's calculus 2, easy. Look at that. I'm using the trigonometry identity everyone know in the life, because tangent is sine divided by cosine. For example, if you're using u like a cosine phi, when you differentiate the u, derivative the cosine is minus sine phi d phi. In order to doesn't affect, I put the negative here and negative here. It's ready to substitution. It's minus integral. Entonces we have du divided by u. Because u is cosine and negative sine phi d phi is du. And what about the limit? Well, the limit is 0 and phi is cosine 0 is 1. It's a 1. Pi over 4, cosine pi over 4 is radical 2 over 2, entonces radical 2 over 2. This situation always happens when the limit and the upper limit is smaller than this, and you have minus here, you interchange. Integral from radical 2 over 2 and 1 du over u. And this is the antiderivative, this is natural logarithm, absolute value. Evaluating between radical 2 over 2 and 1. Okay, entonces logaritmo 1, que by the way is 0, absolute value, doesn't matter, it's positive, the number, minus logarithm radical 2 over 2. Okay, this is 0, and this is, well, by using the property in which, for example, I know that radical 2 over 2 is equal 1 over radical 2, no? The only difference is that when you rationalize, no? Entonces, this is equivalent to say reciprocal of the 1 over radical 2. Entonces you apply the one property, the reciprocal of the logarithm, change the sign. So this is equivalent to say logarithm of radical 2. Yes or no? Positive. Do you follow me? Okay. Entonces, what is the answer? Yes. What is the answer then? Well, the answer is 2 pi. Multiplication by radical 2 and multiplication by logarithm pi. So 2 pi radical 2 logarithm radical 2. Final answer. Okay, this is question 10. Guys, I have no rush. See, we don't finish today, we continue Friday. Maybe Friday we finish and we start new chapter. Or I don't know. The problem is I need to finish and everyone understand very well the review package, because you need to do by yourself the test on paper and the test online. Don't forget. Remember, the due date is June 5th. June 5th is the day in which any student que have pending something is done. Yeah, that's it. June 5th, because we have a new chapter, and this new chapter is completely different to this. It's a vector calculus. Vector calculus, and another university is teaching separately to the multivariable calculus. The multivariable calculus is the upper part, geometry, derivation, differentiation, and integration. Done. Finish calculus 3 in other university. And start new subject is vector calculus, because in vector calculus we are working with a different mathematical object. It's a vector field. We need to understand first vector field, and after you apply calculus to on vector field. Okay, let's move on to the question 10. 10, no, 11. 11 now. 11 question. 11 is, it's easy. 11. Wow, 11 is, is set up. So not necessary computation. No. Set up the double integral on the region bounded by the x squared plus y squared equal 4. It's a circle. Circle with the center is in the origin and the radius 2. And another circle que es x squared plus y squared equal 2y. Que es a circle, but the center is located, I don't know. Let me try to complete the square. And the first quadrant of the function c equal. Okay, so this is my curve. This is double integral plot. Okay, x squared plus y squared equal 4. And x squared plus y squared equal to y. And the first quadrant, no optans, quadrant, 2D problem. And the function is hypothetical function, like that. Okay, so my first goal is try to understand the region. Okay, therefore I take, this is clear, super clear, but this is confused. But no, it's okay. X squared plus y squared minus 2y plus the number que complete the square equal the number que complete the square. And the number que complete the square is obviously 1, no? And 1, where come from this 1? 2 divided by 2 is 1, square is 1. When you are doing this action, this trinomial is perfect square, and the answer is x squared plus y minus 1 squared equal 1. And you see, wow, it's clear for me now. This is a circle. And this circle have the center at the point 0,1, is, you know, the h and k of the circle, and the radius is 1. In this case, the center is located at the point 0,0. It's the classical, no? And the radius 2. Okay, ready. We are ready to do the sketch of our region in 2 dimensions. Wow, easy. 2 dimensions is piece okay for us. Okay, we have a circle here. Wow, no good. Okay, and this radius 2. I got the 2. And we have another circle. We have circle que the center no 0, 0, no, is 0, 1 here. And the radius 1. Okay, entonces our circle look like that. Small circle, because the radius 1. Okay, entonces now my region is bounded in the first quadrant. Así es, in the first quadrant, I suppose que my region is, because I need to say que is inside. The problem say, let me see. Bounded. Okay, bounded. Bueno, bounded, I suppose que sí. Bounded. So we have two boundaries. One boundary is the big circle, and the other boundary is the small circle, and lie in the first quadrant. This is my region. This is my region R. Okay, so first of all, step one, determination. The region, no? I need to understand the region first. Okay, now make a decision. I set out the double integral. And what do you think? You set out in Cartesian or in polar? So you set out in Cartesian, you need to define in what direction you are doing the integration. See, vertical directions are dy first, dx secondly, or polar. Or polar. I suppose it's much better polar, no? Yes or no? Do you understand it's much? Yeah. What is the reason it's much better polar? What is the reason? What is the reason? The reason is dealing with circle here. Okay, always when you have circle, es polar. It's the key idea. Okay, entonces en polar, remember the coordinate is r and theta, and the Jacobian is r dr d theta. Okay. Entonces now ready. Bueno, ready no, almost ready to set out the double integral. Double integral, bam, and that region. Okay, the function is this. The function, no xy anymore. No. I know that x is r cosine theta. I know that y is r sine theta. So you replace. And my integrand function is r cosine theta, comma, r sine theta. And leave it like that because I don't know exactly where the algebra inside this function. Okay, now the Jacobian. The Jacobian is r dr d theta. Done. Oh, the limit now. I suppose that the first stage of the integration is dr. Entonces, I suppose arbitrary position here. Entonces, r go from the r of the small circle to the r of the big circle. Well, the r of the big circle is easy because it's 2. The upper limit is 2. However, I come back. Look. Okay, come back to this equation. Okay, I know that x squared plus y squared is r squared. I know that 2y is 2r sine theta. If you cancel out at least one r is equal to sine theta. And this is the r associated with the small circle. So it's go to the 2 sine theta. It's variable. It's obvious it's variable, depending on the position. No? Suppose in this point, this is the r. However, in this point, this is the r of the small circle, and the r of this big circle stay the same, get 2. No? And what about theta? Theta go from this, get 0. Well, actually, it's the first quadrant. No? Since the first quadrant is obvious, it's from 0 to pi 1. End the story. Finish this problem because the job is only done the setup. Any question? Super beautiful. I like this problem. It's easy. Because I hate the complication for the integral, the algebra. Wow. Because everyone makes mistake. Or possible make mistake. In this case, no, theoretical, clear. Okay. Any questions so far, guys? Okay, answer me. Okay. Okay, let's move on to the 12. 12 now. Bueno, 12 similar. Compute the volume. Oh, it's a volume. Compute the volume. 12. Compute the volume. Volume. Of the surface. Surface of the function, whatever. Que es y squared over x squared plus y squared. Above the xy plane, that means z greater than or equal to 0. And in between two cylinders. Wow. We have two cylinders, right? The first cylinder is x squared plus y squared equal 1. Remember, this is in 3D, is cylinder, no circle. And another is x squared plus y squared equal to. Okay, so basically we have two walk. Cylinder radio 1 and cylinder radio 2. And the roof of this solid is this function. Entonces no super complication. Si you understand very well the 3D, so basically we have two cylinders. I go directly. In this case, easy. In other case, no. We need to do 3D, 2D. No. In this case, 2D, 3D is classical because you apply C simple. And the first integral go. This is C. This is C. From C of that function to 0. Okay, so maybe the complicated part, maybe, is the double integral, no? Pero the double integral, no, it's no big deal. It's in XY, two cylinder. One cylinder with the radius 1, and another cylinder with the radius 2. Okay, so this is our region in 2D. It's a ring. This is 1, and this is radical 2, sorry. Radical 2, no? Let me see at the beginning. Yeah, radical 2. Radical 2. Because the radius is radical 2, no 2. Si es 4, es 2. Okay, our problem say que es 2. Yeah, es radical 2. Okay, super. Entonces now, okay. Entonces I need to compute the volume. Pero, pero we compute the volume using double integral, no? No necessary triple integral. No, double integral, of course, double integral. Compute the volume. On the consideration, double integral in the region R. The region R is this yellow. And you suppose here que es the y. Bueno, es the high, no? The high is the function. The function is y squared over x squared plus y squared. Entonces, dA, because I have no idea si hay integration vertical, integration horizontal, or integration in polar. What do you think? Vertical, horizontal, or polar? Again, polar, because we are dealing for a circle. So I need to change, I need to change the integrand function and the Jacobian, integrand function and the Jacobian. Okay, look. This is y squared. The formula for the integrand function is y squared over x squared plus y squared. I know que y squared is r squared sine squared theta, and this is r squared. Now cancel out, and the answer is just sine squared. So sine squared is our integrated function, theta. Okay, Jacobian now. Jacobian is r dr d theta. Here, double integral. Now, I do the double integral from radio. Well, radio is easy. Radio go from look this to this, always constant. 1 to radical 2, and theta from 0 to pi. You see the beauty of this. This doing by Cartesian is very, very complicated. Suppose you integrate in this direction. This is crazy. What happened here in the middle? I have no idea. However, polar is magic. Okay, now I can separate into integral. The first integral from 0 to pi of sine square theta d theta. You separate the part of the function that contain theta and the part of the function that do not contain theta, case r dr, from 1 to radical 2. Let me try this case easier, in my opinion. Okay, this integral is r squared divided by 2, evaluating between 1 and radical 2. Entonces, well, this is radical 2 squared divided by 2 minus 1/2, no? With the 1 squared over 2. This is 1, and this is 1/2. And the answer is 1/2. Or at least this part is 1/2. Good. And this, well, this is classical in calculus 2. You're using half angle formula. So you need to remember that sine square theta is equal 1 minus cosine 2 theta divided by 2. So you separate this into integral. So you separate in this first integral from 0 to pi of that part que is 1/2 d theta minus another integral from 0 to pi of the cosine 2 theta d theta. I don't know why always happen that part is 0. And makes sense because it's the area in one entire cosine. Doesn't matter. We can do that. You integration this, evaluate, but I skip that because it's obvious. And this no. This is 1/2 outside, and integration d theta theta, evaluating between 0 to pi is pi. The answer is pi. So what is the final answer? The final answer is multiplication 1/2 and pi. The answer is pi over 2. End the story. Pi over 2. Any question? Any question? Any question? Any question? This is for 1, radical 2. This is 1/2. This is pi. Okay. Beautiful. Awesome. Fantastic. Okay, we have 13 and 14. And we left this for the Friday. Friday we are doing 2 problems. That's it. We finished the review. Of course, you are smart and you take advantage and try to do the questions similar in the test of the review. There are no similar questions. And remember, June 5th is our due day for everything, online and on paper. Okay, are you clear or are you confusing? Victoria, are you there? Victoria, answer me. Yes. Okay, stay, because I need to talk to you. Stay in 2 minutes. Entonces, the due day is July 5th. July 5th. Next Monday. Next Monday.